All right, folks, welcome back for another demo roundup. We've got a special edition today where we're going to be talking about operationalizing artificial intelligence. Before we kind of get into things, I've got a couple of important housekeeping items. First, we are going to be showing some forward-looking capabilities. So just our kind of standard safe harbor language here about, capabilities that we haven't released yet may still change. So that's just something important to keep in mind. And now I want to kind of get into what the story is going to be today. We've sort of set it as part of a global media company. But you can imagine this happening in financial services, healthcare, retail, whatever industries. In the main point is that we have this is an organization that has built some capability using artificial intelligence. They've got a feature, a customer-facing feature that is using artificial intelligence. Now, before I really get into the plot here, I'll take this down for a second. I do want to introduce our guests and also plug. We've got tomorrow. We'll have Jose on for another episode of our weekly Terraform time. He's going to be talking about using Terraform to set up incident workflows, which you're going to hear a little bit about today and see it in action. And then on Friday, of course, Mandy will be back with a how-to happy hour. So our guests here today, we've got Jackie Liebman, we've got Ben Miegelman, Jake Cohen, Sam Ferguson, and Frank Emery. You're going to get to know all of them a little bit more as we go through this demo. They are all part of our product management team here at PagerDuty. All right, so this is where we can cue the dramatic music, where the plot thickens. So imagine this global media company that's using machine learning and a large language model to power their newest artificial intelligence feature in their streaming service. Shortly after the big launch, of these features during peak evening hours, several of these AI-powered features begin underperforming. This is ultimately due to models becoming stale for some reason. And the team what you're going to see here is that the team is able to rapidly detect, diagnose, and restore the service with the help of the PagerDuty Operations Cloud. It's going to look easy with what you see today, but this kind of thing is actually pretty complicated, and it's not it's sort of non-trivial to do that. But these types of things happen every day. So just to give you a quick overview of what you're going to see, just so you can have a mental model. This is the PagerDuty Operations Cloud. It's got several different capabilities in it. We're going to first see how global event orchestration is used to define how incoming events are going to be handled across services. So you can think of very sophisticated rules that can be applied to what you want to do with different events. And from there, that is going to go and trigger some diagnostics and state capture that's going to go run, and it's going to actually run across a very distributed environment where there's different security measures and across different hybrid cloud environments. And that's making use of our process automation portfolio. From there, we're going to pull in an on-call expert, and they're going to benefit from actually having the output already from those diagnostics, and they're going to use that to populate a custom field that they're seeing in the incident. Now, from there, they're going to make an observation, and they're going to do something that's going to trigger a workflow to run. And that is going to sort of automate a bunch of different steps of how they want to handle this particular incident. A lot of the kind of usual things you can imagine, starting video chat rooms, starting sort of a chat environment in Slack or MS Teams. One of the things that's also that's going to happen is they're going to make an observation, and they're going to want to send another status update, right? A discovery is made. Then they're going to want to keep their customers in the loop while this is all going on. So you're going to see how the team then updates a public customer-facing status page, but because there are still customers calling in to the customer support line, you're going to see how those customer service agents are able to stay in sync with what's going on with the situation. So from there, let's see, I am going to take this down. I'm going to hand things over to Frank to kick things off and have fun. Okay, Frank, let me get your screen up there.
Cool. So It's nice to meet everyone. So my name is Frank. I'm a product manager here on the AI Ops team. And as Dormain mentioned, we're going to walk through how this global media company made sure that they were ready for launching the new generative AI product, and how they configured PagerDuty to make sure that go live day they were prepared for what would happen. And like all good Ops Cloud stories, we're going to go ahead and start this story off with event orchestration and how events got managed both prior to an incident being created, and then what ended up happening after that incident was created and how event orchestration helped automate all of that. And so to start, what we're going to do is we're going to go ahead and look at how this company made sure that they were ready and prepared for any potential generative AI issues that came up. And what they did was they went ahead and they started by making a new event orchestration for their streaming services product. And they did a couple of really specific things here to make sure that they were getting a full view of all the potential events that could be coming up. And the first thing they did was they actually combined three different integrations, three different event streams into a single event orchestration. And this is really important because what this means is that when they're deciding what to do with events as they're being ingested, they're actually deciding across all of their event data. So, in this case, they're using three different tools for tracking what events are coming in. They're using Monte Carlo monitoring to keep an eye on all the data. They're actually ingesting their chatbot support queue, and they're looking at all their AWS monitoring as well. And by funneling all of this data into a single place, they can do cross-service correlation as well as cross-observability tool correlation. And they've actually gone ahead and done that. So with all of these integrations set up, they went ahead and they used global event orchestration to create a couple of rules that are going to manage how event-driven automation occurs across these different sorts of data sources. And what they've gone ahead and done is they've broken their event data into two core streams. So one stream really looks at how machine learning is performing. This sort of the top stream here. It's looking for any issues that might be happening with models or with model training that could lead to a degraded customer experience. And the second stream really focuses on whether or not their data warehouses are working properly. So is data coming in? Is it accurate? And all that's really important to make sure that your machine learning models have what they need in order to be properly trained. And for this demo, what we're really going to focus on is this top row that's looking at whether or not models are being trained properly and giving results that they need to be given to customers. And what these folks have done is in just a couple of clicks, they've made three rules that are going to detect whether or not models are working properly. They're going to dynamically suppress notifications, giving models time to recover before incidents are triggered. And then finally, if there is a sufficient number of issues that are raised for users, they're going to automatically create a high critical incident and route that to the appropriate team. And this last rule here is actually the one that's really important and interesting. And so what we're doing here is we're actually looking for 100 different events across any of these different monitoring tools that haven't self-resolved. So by the time this rule triggers and sets something to a P1, we already know that a substantial amount of customers are reporting an issue. It's an issue that hasn't self-resolved, and so it's something we actually want to pull responders in on. The next thing these folks have gone ahead and done is they've set up some routing rules to make sure that these events are going to the right teams. So machine learning issues are going to the machine learning team. Issues with data warehouses are going to the mainframe team. And this is really important because at the service level, what these teams are able to do is start kicking off really precise automations. What we find is at the global level, it's really helpful to do sort of broad sweeping rules that can normalize event data, help with event routing. But at the service level, this is where teams can come in and start defining really specific automation that can make sure that when an incident's created, it has the information needed to get production back online. And we'll see here that's what this team has actually done. So they've configured it so that any incident that actually makes it to this team actually gets triggered, lets folks know that an automation has been run. It lets folks know exactly which automation has been triggered so they know what diagnostics are going to be available, and it will automatically trigger those diagnostics. And so if we go ahead and look at this team, I suspect we'll see a major incident has actually come in, And we can take a look at everything that event orchestration has automatically done for these responders before they've even picked up the phone. So we can see here that a major incident did actually get triggered. If we look at the timeline, we'll see that some event orchestration rules were applied. And then we'll also see that an automation action was automatically kicked off and a note was added indicating that. So event orchestration has gone ahead and prepped the incident, added in all the necessary information, and triggered automation for our responders. And with that, I'm going to go ahead and kick things over to Jake, who's able to walk through a bit more about what automation happened here.
Excellent. So as Frank mentioned, once the incident was triggered, it automatically kicked off an automation action using our process automation product. And what we're looking at here is data that typically would be manually retrieved by a domain expert who understands the service inside and out. But as we all know, that person may not always be on call. You might have a kind of a tier one on-call team, or you might have a more junior member of the team that doesn't know exactly what to look at for every type of incident that comes in. And so even while you may be monitoring for this data, it's always helpful to bring in as much context to an incident as possible, such that the on-call responder it has that assistance to better start investigating the issue and know where to begin troubleshooting, or know whom to pull in for assistance. And so with that, what we're looking at is a couple of diagnostics that were automatically pulled in, some metadata about the model that was being used for the data streaming service, and some data about the model. And so what we'll do to help explain what we're looking at is show a little bit about how that data was pulled. So we'll jump into Runbook automation, which is the product that was used to retrieve this data. And you can see that there's a number of steps that were carried out. And these steps are a mix of using API calls, command line calls, it could be SQL queries, all sorts of protocols. And it's a mix of talking to public APIs from SaaS products that the team uses, as well as their internal infrastructure and applications. And to briefly explain how that's done, it's using what we call a runner. The team has installed a runner behind their firewall inside their environment that is able to talk to their infrastructure and securely communicate back to PagerDuty's SaaS Runbook automation product. And so we can see here, right, step one is clearly defined, that we're looking at the model version, when it was last trained, and we convert that to how many days old is the model, and whether or not that's considered healthy. Again, the on-call responder may not be a data scientist or machine learning engineer or ML ops engineer. They might not know what is considered good or bad in this case. And so being able to transpose this into something that they can understand is helpful for an on-call that wakes up in the middle of the night for this page. And so then we're also pulling for the last time the data warehouse was updated, right? So we have an ETL pipeline or a streaming service that is pushing the most up-to-date data to the data warehouse. And we can get a hint here that it's been quite a much longer time since the data warehouse data has been updated. And that is considered unhealthy. And this is where the responder is able to hone in their focus, maybe look at other alerts in PagerDuty related to the streaming data upload service, and cut down on the time needed to investigate and troubleshoot. This was kicked off automatically, and actions like these could be kicked off ad hoc from the incident itself. But in this case, regardless, it has cut down the time that it takes to do this investigation. And the team is using process automation ROI feature to track how much time they've saved each time this type of automation has been invoked. And so you can see here what they've said is that anytime that this job has been kicked off, whether that's event-driven through event orchestration, as Frank showed, or it's been kicked off ad hoc by the click of a button or a tap of a button on your phone. They're saving 30 minutes, right? So half an hour. And what they can see is how long this job took. And what they're able to do is pipe this data to a BI tool and track over time how much time are they saving by using this sort of process automation. And so going back to the incident, wrapping this up, we can see that very clearly it wasn't the model that was out of date. It was the data warehouse data that was out of date. So even though a new model was being produced and trained, it was being trained on stale data. And then the last piece here, Dormain mentioned that what we're able to do with our process automation tool here is state capture. We're able to capture data that is only available at the time that the incident has occurred and save it for later so that in either in post-mortem or if there are any tech debt tickets that come out of an incident like this, our developers are very easily able to either replicate the issue or hone in on what might be happening at the code level to better prevent an issue like this from happening in the future. And so with that, I'm going to turn it over to Sam.
Thank you, Jake. So now that we've run through event orchestration and kicked off some automated diagnostics, imagine that I'm the first responder who's paged for this incident. And thanks to what we just saw, we now have some automated diagnostics. So I land on the incident details page, and I'm able to see these logs that Jake just went over. And immediately, as he called out, I'm able to notice that the component streaming data upload is where the impact is. And I know this is high impact, and I know this is a major problem. And so what I'm going to do as a responder is I'm going to take a few steps. With our new custom fields feature, which is GAing this week, I'm able to capture some data about the incident impact. So I've set up a few fields. I have an environment field, a component field, a customer impact start time, and a runbook field. So I'm going to go ahead, I'm going to open these up. I'm going to specify that it's a production incident, so it's impacting our production environment. I'm going to specify that that streaming data is what's impacted. That's the component that's impacted. Runbook is already set, and customer impact start time, I don't yet know that, so I'm going to leave it as is. When I click save, those fields are going to be updated on the incident. So now next time a responder joins this incident, or if anyone else is pulled into our response, they immediately have this information at their fingertips. And soon this information will be leverageable across our product too. You'll be able to use it in status updates, other areas like incident workflows, and again, across our product, which is really exciting. But okay, so I've set some data. So now responders who join the incident have some context. Next, I'm going to increase this priority to P1 because I know that this is a major incident with serious impact. So what that's actually going to do is it's going to kick off this P1 incident workflow that I already have set up. There are a number of steps that I've put into this workflow, and this is actually a pretty standard workflow we see a lot of our customers use. First off, I have a conditional trigger set up. This conditional trigger says that whenever the incident is a P1, so priority is P1, it's automatically going to get kicked off. I have a manual trigger as well, so responders could kick it off from the page we were just looking at it, from the mobile app, from many of our integrations, including Slack and MS Teams, or via API. And I also have a number of actions. So these actions spell out exactly what should happen. The first two are pretty basic around setting up collaboration. So this create a Slack channel one is really helpful. It allows you to create a specific Slack channel for the incident. And you can actually customize this. So here I have incident number as the Slack channel name we're using, but you could customize this as you need. Also leveraging our reference variables to pull in specific attributes of the incident into the Slack channel name. I'm going to leave that as is for now. I also have a Zoom meeting, which I'm creating and adding to the incident. I'm going to add a set of responders who I know are critical for a P1 incident response. And I'm also going to send a status update, basically telling a lot of our stakeholders that there's a P1 incident ongoing and that we're going to give a further update in 5 minutes. So if I jump back to the incident, we're going to see that a number of these steps have already happened. You'll see the responders were added on the right here. I've added a note, and the conference bridge is now accessible via this page. The Slack channel is added. And if I go over into the status updates view, you'll see that a status update also went out to our stakeholders. So that's one way you can use incident workflows and custom fields together to start helping organize and kicking off an incident response. There are many other actions you can include in this type of incident workflow that can fit around your organization's need. And custom fields are fully configurable too. So you can capture data that's unique to your business needs or to the business response process that you have. So with that, I'm going to hand it over to Ben, who's going to walk through status updates in more detail to talk about how you can communicate status updates when an incident is already ongoing.
Yeah, thank you, Sam. Generated AI status updates. I will show you a preview of a feature we are currently working on, and we're happy about feedback about this feature if this fits your needs. My name is Ben. I'm based in Lisbon and the product manager for the services, object, and status update, the feature we will see in a second. Imagine I'm a first responder, and I'm responsible for the communication to all the stakeholders. They want to know what's going on. And here on the slide, you see steps of an incident, right? An incident is triggered. At one point, it's acknowledged. At the end, a responder set it to resolved. But there's a lot of communication happening between step 2 and 5. And most of this communication is happening outside of PagerDuty. For example, on a Slack channel, MS Team, or even in Jira tickets. And here you can see an example how it looks like in the Jira communication. Right here on the right side, you see they are talking about 500 error API gateways, and that the API server was losing connection to the DB, to the database. And now AI comes in play. So here, the purple steps, these are the steps where we want to help you with Gen AI to create these status updates based on conversations you had in a Slack channel or on notes in PagerDuty or MS Teams. Let me look into the product. Here we have our incident. Here on the top, I can send a status update, or here on the bottom, I will show you later, there's a tab where you have even more details. And let me go in here. This is our status update feature. What you see here on the bottom are fields which I preset. It's a feature we released early this year, which we call status update templates, where I can define what kind of fields show up here. These are system fields from PagerDuty, and pretty soon you will have also custom fields which you can integrate here. You have a library of fields, maybe 50, 60 fields, which you can add here and create the right template for you. But now I want to write this personalized message based on the information my colleagues shared in the Slack channel, right? And maybe I don't know what a 500 error is and how to translate this to the stakeholder. Now I have the feature here to create an internal stakeholder update. Let me click the button. Here we have the first message, which was generated. I hadn't to type anything. It was just the click of a button. Now imagine 20 minutes are over. There's more communication on the Slack channel, and I want to send a new status update. Let me go back here, and I will just generate a new status update. This is number 2. Maybe 20 minutes later, I want to say, okay, let me create the next one. Is there new information? Oh, it seems there was no new information found, so that was the latest update we saw here. When I go back to an incident, after I press send update here, I can see here in the status update and the kind of timeline, my different messages. These messages are displayed here on the incident. They are displayed on the internal status page. They are communicated via SMS, via email, and Slack channel. So these are the different channels where we will blast out your message here. Let me go back here and show you one more other case I can do. Now imagine I want to write a message manually, and I'm writing pretty quick and I have a lot of typos here. You see everything is red. In this case, I can just go here and say improve writing. And the writing was improved. Another feature we have here is this at the beginning everything was written for internal stakeholders. So it's very technical people, right? They know what an error, 500 error is and so on. But maybe I want to communicate this also to the leadership, the business leadership, which doesn't have so much technical background, or even to external customers. In this case, I can go here and just say, hey, can you rewrite this with a different tone, addressing the other persona? I hit set update. And again, oops, don't click too much. The messages are showing up here in the timeline. And here's also the place where you can add more subscriber to your stakeholder notifications. That's from status update from my side. I would like to give it over to Jackie.
All right, everyone, I'm Jackie, product manager. And for the purpose of this demo, I will be a customer support agent here at the media company. So as you probably know, availability and reliability are paramount for customer retention and satisfaction. When interruptions in digital service used to happen before we had the PagerDuty status page, our business used to experience high volume of support tickets asking for the current status of issues. PagerDuty status pages, which was GA'd in January, provide us with visual real-time insights into our organization operation and the status of incident resolution. As a customer support agent, I can now proactively and securely communicate real-time operational updates with our customers directly from the PagerDuty platform, and eliminating the need to context switch to other tools and giving us one platform, PagerDuty, as the single source of truth. What's unique about the PagerDuty status pages solution is that my team can benefit from PagerDuty's end-to-end Operations Cloud platform to easily keep both internal and external stakeholders informed during large-scale outages and events. So with that, let's see a quick demonstration of how the external communication piece comes into play. Unlike other status pages solutions, PagerDuty status pages is a tightly integrated product with the PagerDuty platform, allowing me to immediately see the triggered incident while also leveraging human-in-the-loop automation. I can easily see the pending request waiting for my review, which already has all the information about the incident and the impacted service as well. I have the option to apply a template for quick reusability that helps me improve trust and speed up the communication process while ensuring a consistent way of external communication across the organization. Once I go ahead and submit it, it will be immediately available on our status page, which can be publicly accessed by our customers. The end users can easily monitor the system status. They can subscribe to receive real-time notifications via email, Slack, and webhook. And they can also see and subscribe to any of the specific components that our company has chosen to proactively communicate using this status page. So in this example, our team was looking to improve proactive communication with our customers and eliminate the need to context switch to other tools during outages. And now our customer support agents have one platform, PagerDuty, as the single source of truth. Another big offering that our customer service team has been using in PagerDuty is the CSOps integration with Salesforce. Our team is tasked to be proactive with customer experience to drive growth. Before using PagerDuty CSOps integration with Salesforce, our team had a lack of visibility and access to real-time data. We also used to operate in a reactive mode rather than proactively monitoring issues. The CSOps Salesforce integration empowers us to get proactive and maintain visibility of our support cases from beginning to end, full case ownership, which helps us build better customer experience and job satisfaction. As you can see here, the PagerDuty incident was immediately created in our Salesforce cases, allowing myself and our customer support agents have full visibility into any issues and outages without needing to spend time on firefighting and reaching out to the engineering teams, allowing both them and ourselves to focus on what really matters. This case is already linked to PagerDuty, and any new updates will be immediately reflected here as the engineering team is working on resolving the issue. It's a bidirectional integration that actually works both ways, and in cases when a potential incident is reported by our customers, we can easily create an update here and it will trigger the appropriate workflow in PagerDuty, and if approved, we'll post an update on our status page as well. that's all from me. Back to you, Domain.
Thanks, Jackie. And I'll just bring everybody back for just kind of closing out. So thanks, everyone. This was great to sort of just see that whole flow end to end. And I loved that it was in the context of such a hot topic these days where everyone's trying to get better and smarter about how to operationalize these types of features in their products. And so really appreciate everyone, Jackie, Ben, Jake, Sam, Frank, all the work that you've done to pull this together. And thanks everyone for joining live. We'll see you all again next time. Remember to tune in to Terraform Time tomorrow and How To Happy Hour on Friday. Bye now.
Thank you all. Bye.